Alright, so for example 5 and 6, if you want to go ahead and pause the video and try those on your own and then just come back and check it, that's totally fine. Otherwise, I'm just going to go ahead and get started. I went ahead and wrote the factors down already for the A term and the C term. And this one, I actually noticed that my B value is kind of large. So in that case, if you have a larger B value, sometimes it actually does benefit you to start out with the more extreme values. So I am going to go ahead and just start with 1x and 6x. Oh yeah, let me jump the gun here. Check for GCF. Sorry, so I just initially saw there's no GCF. But we always factor out GCF first. So there's nothing in common between all these terms, so no GCF. I just got a little quick on that. Okay, so I went ahead and tried 1x and 6x. So now the only option for my C value to try is a 1 and a 2. So I'm going to go ahead and fill in a 1 and a 2. Okay, check my inner product. 1 times 6x is 6x. And 1x times 2 is 2x. Well, 6x and 2x do not give me 11x, so clearly I tried the wrong combination first. So I'm just going to swap these guys around. Always try both directions first. So I'm going to make sure for a fact that 1 and 2 do not work. So I'm going to go ahead and swap places. So 2 into 1. 2 times 6x is 12x. And 1x times 1 is 1x. So yes, 12x and 1x do give me 11x if I make that 12x a negative and that 1x a positive. So I want my inner product to be a negative value and my outer product to be positive. Let's always check our C values at the very end. So how do I get a negative 2? Well, that's negative 2 times positive 1, so that guy works out. Double check again. Negative 12, positive 1 is negative 11. And 1x times 6x is 6x squared. So we took care of that guy properly. So let's go ahead and just write our answer down. So x minus 2 and 6x plus 1. Okay, you can write 1x or just x, either is fine. Okay, looking over at number 6, let's not jump the gun here. Let's definitely check the GCF first. Hopefully it's pretty evident there's a GCF in there because they're all even. So I'm going to go ahead and take out a 2. So I'm going to factor out a 2. I'm going to divide all the terms by 2. When I do that, I'm going to get x squared plus 11x plus 30. This is actually super nice because now I have a leading coefficient of 1, which takes us back to our examples from like the day before yesterday. So I can go over here and do my little x, and what multiplies to be 30 but adds to be 11? Well, if you think about those factors, 5 and 6. 5 plus 6 is 11, and 5 times 6 is 30, and they're both positive because those signs worked out. So this guy is actually done. Bring down your GCF. Don't forget, when I'm doing it with the leading coefficient of 1, I just copy that variable on the inside, and this was a positive 5 and a positive 6. So that guy, once you did GCF, he actually became a pretty easy problem. Making our way to the back page here, we have special products. We're going to talk about difference of squares first. Difference of squares is my favorite formula because it is the easiest one we have. It's always really evident you have it immediately because you have two terms only and you have a minus sign. This only works for differences. This formula only has a minus sign in the middle. Our factored product has a plus and a minus, but the original problem only has a minus. So I can see something minus something. Every one of these has two terms and has a minus sign. Okay? So to do these are really, really easy. You've got to make sure, firstly, you have a square, which means something multiplied by itself. So is y squared something times itself? Yes. Well, it's y times y. Is 9 something times itself? Yes, it's 3 times 3. So then your product is just the first plus the second and the first minus the second. So y plus 3 and y minus 3, and you're done. Okay, always check for GCF as well, but this next one, 4 and 25 don't share anything. So what do you multiply to get 4x squared? Well, that's 2x times 2x. What do you multiply to get 25? Well, that's 5 times 5. Your answer is 2x plus 5, 2x minus 5. So these are super, super nice. I love these problems. All right, this one here, You actually could. 64 is a square. It's 8 squared, and 16 is 4 squared. But these guys actually have a GCF. 16 actually goes into both of them. So you do actually want to go ahead and factor out any GCF starting out. So 16 goes into 64 4 times, and 16 goes into negative 16 negative 1 times. This still is going to be a difference of squares. So I can still go ahead and factor this guy down, but at least my product will be all the way factored as opposed to, I'll show you what it would have been if we didn't factor. How do I get 4x squared minus 1? Well, we just said 4x squared was 2x times 2x, and 1, let's go ahead and change colors. So 4x squared is 2x times 2x, and 1 is 1 times 1. So my answer is 16 parentheses 2x plus 1 and 2x minus 1. It doesn't matter if you write y minus 3 and y plus 3. Like, it doesn't matter what order you write it in. I would just write plus and minus. Doesn't matter. But as long as you have 1 plus and 1 minus, doesn't matter what order. It does matter, though, if you wrote 1 minus 2x. That matters. You've got to write the first term first and the second term second. Okay, so real quick, if you did not factor this guy, the GCF out, you would have gotten, that would be 8x plus 4 and 8x minus 4. So that would have been your answer, but that would not be completely factored. So that's still correct, but not completely factored. So your final answer should be this guy right here. All right, looking at this guy, I do see 2 terms. But hopefully you recognize that 3 is not a perfect square, which must give you a hint. If I don't have a perfect square, either it's prime or there's a GCF. So does 3 go into 48? Well, yeah, it does. So I'm going to factor out 3, leaving me m squared minus 16. And then, well, m squared is m times m. 16 is 4 times 4. So my final answer is 3. M plus 4 and M minus 4. So these guys are super easy and quick as long as it only has a difference. So if you have a plus sign, you automatically can't do it at all. So it's got to have a minus sign in the middle. Make sure they're each perfect squares. If it looks like they have a GCF, always factor a GCF first. If it has a subtraction sign but it's not factorable as is, then it's probably got a GCF. Just be mindful of that. Go ahead and check it out, and these guys are not too bad. Our next special products are perfect square trinomials, and this one has 3 terms in it. Obviously, it's a trinomial, and it's defined by the first term being a perfect square, and the last term being a perfect square, and the middle term, the b value, comes from the first times the last times 2. So let's look at this. So this guy's a perfect square trinomial. I'm going to look at what the square of this guy is. So x times x. What's the square root of 9? Well, that's 3 times 3. As long as your middle term is 2 times your first times your last, so 2 times x times 3. Well, that does give me 6x. Then I can just go straight into my solution. So whatever sign is here is what sign's in my answer. So plus sign here, minus sign, minus sign. Whatever sign is there is in your answer. So my answer is x plus 3 squared. Done. But this is not as obvious to spot right off the bat, so I'm just going to show you can discover it without even doing the formula. This has a leading coefficient of 1. What multiplies to be 9 but adds to be 6? Well, 3 times 3 is 9 and adds to be 6. I would have written this on my own without the formula. I would have written it as x plus 3 times x plus 3. So the perfect square trinomials mostly just allow us to take, if we have the same factor twice, to write our factor as the factor one time with a square. So we're not going to write it like this. We're going to write our answers like this. So even if you arrive at your answer some other way, your answer is still going to be that factor written one time with a square on it. So if you can't recognize this right off the bat, that's okay. It does make life easier. But if you don't spot it right off the bat, you can easily just book, oh, that's my answer, and then square it. Okay, so going down here, is my first term a perfect square? Yes, that's 7x times 7x. Is my last term a perfect square? Yes, it's 1 times 1. What's my sign going to be? Well, there's a negative here, so I'm going to have a negative inside. So it's going to be 7x minus 1 squared. If you didn't spot it that way, you could do what we just learned today, actually. You would go through the factors here, which is either 7 times 7 or 49 times 1, and then just check your outer and inner products. So you can always arrive at this exact same answer some other way, but if you can spot the first term as a perfect square, and the last term is a perfect square, and the middle term is 2 times 7 times 1, that's 14, then it satisfies the perfect square trinomials. You can write your answer as one factor with a square on it. So, but even if you get the other answer, if you ended up writing 7x minus 1 times 7x minus 1 by doing the guess and check method, just write your answer like this and you're still good to go.